Welcome to this explainer on Cambridge 9618 testing methods. Have you ever looked at a Cambridge computer science past paper and felt like you were staring into the matrix, like there's a hidden language you just aren't speaking? Well, I'm here to tell you that there is no paper. There are only patterns. Once you learn to see the code behind every single question, you can crack any exam. Today, we're decoding exam reality by looking at a foundational topic that appears in virtually every single examination series: alpha, beta, and acceptance testing. Whether you're studying syllabus 0417, 0478, 0983, 0984, 2210, the older 9713, or our main focus today, the 9618, the strategy is exactly the same. We constantly see two types of candidates fail these questions. First, there's Alex. Alex overloads his answers with raw computer science facts but provides zero analysis. He memorizes the textbook but gets a C. Then there's Sam. Sam rushes. Sam completely misses the command word requirements and leaves massive points on the table. We're going to fix both of those approaches today. Let's get right to it.
I want you to look really closely at this direct quote from the examiner reports. It is absolutely crucial. The assessment framework prioritizes analytical depth over superficial breadth. What does that actually mean for you sitting in that exam hall? It means examiners are actively hunting for deep, logical reasoning. They are literally trained to ignore surface-level memorization. When Alex writes down a perfect dictionary definition of testing but doesn't apply it, the examiner gives him maybe 1 mark. To succeed, you have to show a connected, conceptual understanding. You have to prove you understand why a testing method is used, not just what it is. This is where top students use the Peel framework: point, evidence, explanation, link. We'll be using this extensively today to show you how to structure those perfect, high-scoring answers.
So here's our roadmap for today's session. We are covering the core principles, the procedural framework, securing those vital method marks, the top examiner warnings, and finally, the ultimate deconstruct, solve, and evaluate cycle. Let's dive into Section 1, Core Principles, where we properly define these testing phases so you never lose the easy marks. Okay, confusing terminology is a massive roadblock for so many candidates, so let's clearly define these phases right off the bat. Alpha testing is purely internal. Think of it as your absolute first line of defense. This is where developers, the actual people inside the organization who built the software, rigorously test it to identify bugs and glitches before anyone outside the organization ever lays eyes on it. It's basically an in-house simulation of how the software will act. Now, if the exam asks you to explain alpha testing, Alex would just write, "It is tested by developers." Bam, 1 mark out of 3, but you're going to use Peel. You'll make your point, it's internal. Your evidence, it's done by the original coders. Your explanation, to catch catastrophic bugs in a safe environment. And your link, connecting it back to the specific software mentioned in the question. That is how you get full marks. And hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Once those internal bugs are squashed, we move outward to beta testing. This phase is incredibly interesting because it brings in a sample of real intended users. The software is released into a live real-world environment. These users interact with the product naturally, uncovering unexpected issues that developers simply couldn't predict in a sterile lab setting. This is where Sam usually messes up. Sam sees the word beta, rushes, and writes, "Users test it," completely ignoring the command word in the prompt, which might say, "Evaluate the use of beta testing for a new mobile game." You have to evaluate. You have to talk about how a real-world environment introduces unpredictable user behaviors, different hardware configurations, and network stresses that the internal developers in the alpha phase just couldn't simulate. See the difference? We are decoding the command word. Finally, we reach the big boss, acceptance testing. This is the ultimate check. The purpose here isn't just to find missing semicolons or code bugs, it is to verify if the software actually fulfills the original business requirements it was built to address. Is it truly ready for deployment? Does it do what the client actually paid for? If the client asks for a hospital database that processes patient intake in under 5 seconds, acceptance testing measures exactly that. If it passes this, the system is generally accepted and handed over. Remember, this isn't about code efficiency anymore. It's entirely about business compliance. But here is a fascinating challenge that comes up constantly in the examiner reports. Why do candidates struggle so much with interpreting complex binary representations during these testing scenarios? We often see students completely freeze up when data interpretation is required. Imagine a question where a beta test outputs an error log, and that log is represented in complex binary or hexadecimal formats. The exam asks you to extract that data while explaining the testing phase.
If you just memorize textbook definitions, you're gonna panic. But if you're seeing the matrix, you realize this is just a two-part puzzle. Decode the binary, then apply the Peel framework to explain why that specific error matters in a beta environment. It's all connected.
Moving right along, let's look at Section 2, the procedural framework.
So how does algorithmic thinking actually apply to these testing frameworks and help solve that exact problem we just talked about? It requires a highly structured process, what we like to call the computer science success blueprint. You must systematically decompose the problem step by step, then choose the appropriate data structures, implement efficient code, and finally apply rigorous testing, alpha, beta, and acceptance. You don't just magically jump to the end, you build your solution logically. When examiners look at your paper, they want to see this blueprint in your answers. They want to see that you understand the software lifecycle is an interconnected loop, not just a bunch of random phases.
When you are faced with processing a system test in an exam question, you absolutely must follow this standardized sequence. First, identify the key elements. What is the software? Who is the user? Next, apply the relevant principles. Then, execute your analysis with clear, documented working. After that, verify those results. And finally, present them in the exact format the command word asked for. If the command word is describe, your format is different than if it's evaluate. If you follow this exact 5-step sequence, your answers literally transform from a mess of red pen marks into beautiful green check marks. You leave absolutely no room for examiner doubt.
Let's move to Section 3, securing method marks. This is where the magic really happens. Listen up, because this is the secret sauce. Examiners award points for your process just as much as your final answer. Let's compare a context-free answer versus a context-specific answer. The syllabus strongly emphasizes that top-performing students always transfer their conceptual understanding to the specific, unfamiliar context given in the question. If you just recite the generic definition of beta testing without applying it to the specific scenario provided, let's say a hospital's new intensive care database, you are losing vital method marks. A context-free answer says, beta testing finds bugs with real users. A context-specific answer says, beta testing the hospital database with real triage nurses ensures that the interface is efficient during high-stress real-world emergency admissions, uncovering usability flaws the developers wouldn't see. Boom! Maximum marks. And speaking of maximizing your potential, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
So, tying it back to securing those marks, the crucial point is demonstrating your data interpretation skills explicitly. Think of this as a mini interactive workshop right now. If I show you a complex data table of test results, your first job is a rapid data scan. Extract the core trend. To secure those method marks, ensure you clearly show your step-by-step working when extracting binary data, performing your calculations, and drawing your evidence-based conclusions. Don't hide your thought process in your head, put it on the page. The examiner can't give you marks for what you were thinking, only for what you wrote down. Show them the math, show them the logic, show them the evidence.
All right, let's flip over to Section 4, top examiner warnings. This is straight from the people grading your papers. We've dug deep into the principal examiner reports, and they highlight specific, painful mistakes that candidates like Alex and Sam make year after year. According to the data, there are exactly 3 major pitfalls regarding testing methods that you must actively avoid if you want an A star. We're going to play a quick mental game of find the flaw with ease. Let's reveal them. Number 1, never confuse cause and effect. Candidates constantly mix up the bug itself, the cause, with the system crash, the effect. Be crystal clear on what triggered an error versus the resulting failure during an alpha test. Number 2, always remember to check your boundary conditions and edge cases. When asked to provide test data, students always remember normal data and abnormal data, but they completely forget the extreme boundary limits. That's a guaranteed dropped mark. And number 3, which we literally just workshopped, answers lacking the specific context given in the question. Ground every single sentence in the provided scenario. Generic answers equal generic grades. It's that simple. And here is a massive, flashing red examiner alert for you. The reports reveal that candidates consistently confuse key terminology in the heat of the moment. So your golden rule for any high-mark question is this: always clearly define your terms before diving into an extended response.
If the exam asks you to compare alpha and beta testing, take a breath and take 30 seconds to speed write a flawless PEL paragraph defining both briefly at the start of your answer. This anchors your entire essay and immediately shows the examiner you know exactly what you're talking about. Now, since exam pressure can make your mind go blank, a brilliant memory hack to help with this is to create your own mnemonic using the first letters of testing terms. Alpha, beta, acceptance, ABA. Think all bugs addressed, or always be analyzing, or maybe something funny that you'll definitely remember. Whatever works for your brain, lock it in. Create one right now so you literally never mix them up when the clock is ticking down and you're sweating over an 8-mark question.
Finally, let's bring it all together in Section 5. Deconstruct, solve, evaluate.
This is the ultimate problem-solving cycle for those tricky, higher-order questions that separate the top tier from the rest. 1. Identify the given data. Read the scenario twice. 2. Break it down into logical steps. 3. Solve it systematically using the PL framework. 4. Pause. Check if your answer is actually reasonable. If your calculation says the beta test took 400 years, you've messed up. And 5. Finish with a justified recommendation based on your findings. This completely aligns with our 3 rules that guarantee top marks: command word decoding, PL framework application, and managing your time effectively through a matrix.
To achieve those top syllabus bands, your critical analysis must prove that you can go way beyond just listing testing definitions. You need to be able to evaluate alternative methods. You need to clearly compare different testing approaches, like why beta is better than alpha for uncovering usability flaws, but worse for structural code integrity. And ultimately, you must provide justified recommendations. It's all about proving to the examiner that you understand why a particular testing method is the absolute best choice for the specific, messy, real-world situation they've put in front of you.
So, as we wrap up this explainer, the ultimate question I want you to take away is this. Are you just memorizing facts about alpha, beta, and acceptance testing like our friend Alex, or have you mastered the conceptual depth required to decode the matrix and apply these methods to absolutely any unfamiliar problem the exam throws at you? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainer videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing right now. Our team genuinely responds to every single comment. Like and share this explainer with a study partner who needs it. Ace the Exams, your Cambridge success starts here. Keep analyzing, and I'll see you in the next one.